Yes, my students, last time I taught you, I solved the problem of practice set 3.1. Now in the topic circle, before solving the practice set 3.2, there are some theorems, or you can say only one theorem here, and with the help of this we are going to solve the practice set 3.2. Therefore, first I am going to take this theorem. Okay. Now, what is the theorem? Theorem of touching circle. Theorem of touching circle. Now see here, what is theorem? If two circles touch each other, their point of contact, here see, this is the point of contact C, lie on the line joining their center. The C, this point of contact, lie on the line joining their center means this point C is on the line segment AB. Similarly, here, now see here the circles are touching externally. Here the circles are touching internally. But in both the cases, the point C will lie on the line. If you are going to draw a line here, I am going to draw a line. Okay. I am going to draw a line from here passing through this must here. Okay. I am going to change its color so that it should be more darker. Yes, now see here this point A, B and C, they are at a line. The things are here given. If two circles touch each other, their point of contact, here the point of contact in both the cases, C lie at the line, on the line joining their center. Here this is the line AB joining their center here also. Okay, and here remember this, the first is the only theorem. Here the second and third, it is given regarding the if they are touching externally and if they are touching internally. Then what is given? If the circle touch each other externally like this, distance between their center is equal to the sum of their radii. Means here that this distance, you want to here this distance AB. Okay, this distance is equal to, means distance AB will be equal to sum of the radii of these two circles, that is AC radii of this circle plus radii of another circle. Okay, if you will represent it by R1, suppose its radius is R1, its radius is R2, then distance AB will be equal to R1 plus R2. That is the sum of the radius of these two circles. Now see, the third one, the distance between the center of the circle touching internally is equal to the difference of their radii. Here see, these two circles are touching internally. Okay, if you will consider that AC is here, this AC is R1 and here this part is as R2. Then the distance here, distance I'm writing here, distance AB in this case will be how much? That is distance AC minus distance BC. Okay, you can see this distance AB is equal to AC minus BC. If you have considered that this is equal to, as I told you, that this is equal to R1, then what will happen? Distance AB is equal to R1 minus R2. This is given here in the, remember this, the third point is, that is the distance between the two centers is equal to the difference of the radii. Okay? Using these properties, we are going to solve the practice set 3.2. Okay? Now see here, we have already drawn the figure here. See the practice set 3.2. Two circles having radii 3.5 centimeter and 4.8 centimeter touch each other internally. Find the distance between their center. Okay, here, see here, two circles, one is having radius 3.5, second is having radius 4.8. See here, because it is possible for me to draw 4.8 and 3.5. What you can do, you can draw any circle, okay, and consider it. Don't draw the circle of the given value. Draw a circle like this, whatever it may be, and consider its radius equal to, now see, consider its radius equal to 4.8. It is 4.8. Draw another circle and here is like this, and consider that its radius is how much? Its radius is 3.5. I'm going to draw here this. Suppose this is 3.5. I'm showing it by that's different color. Okay. This is how much? Here this is 3.5. Okay. It means in the diagram it's not necessary to draw the exact measurement. Okay. Because it's possible for me, therefore I draw it as 4.8 and 3.5. Now see here, let this radius, this 3.5 is equal to R1, and this 4.8 is equal to R2. Okay? Here, this OP, all these things are not given. Therefore, you have to consider it. that I am going to write here. Let the two circles of center Q and O touching each other at point P, then what happened? Now two circles touching at point P, then as per figure, what will happen? That R1 is equal to QP is equal to 3.5 centimeter and R2 is equal to OP is equal to 4.8 centimeter. You have to first consider this thing. Okay? Now he is asking the distance between their center. What is the distance between their center? That is OQ. Okay? Therefore, you will write here distance OP is equal to distance OQ plus distance QP. Why so? Because they are touching internally. Okay, this is due to the theorem of touching circle. Okay, that they lie in a single line. Okay. Now OP is given how much? OP is how much? 4.8. Here you have to find out OQ, that is the distance between the two circle center, and here this is 3.5. Therefore, here distance OQ is equal to 4.8 minus 3.5. Okay? Now I am going to write here on the next page, that is 4.8 minus 3.5 is equal to distance OQ, and this is, if you will subtract, it will be 3.1. I am writing here it in this form. Distance OQ is equal to 1.3 centimeter. Okay, this is your answer. Now see here, while writing this, you have to use the theorem of touching circle. Okay, you don't subtract initially that OQ is equal to OP minus QP. You write like this: distance OP is equal to OQ plus QP, because they are on a single line. Okay, therefore By using here, take it to the left hand side and subtract it, you will get the answer. Okay?